Having tailor-made stem cells gives you the advantage that if a patient needs a certain type of cell, and these cells are tailor-made to the body, so they don't see the body as being foreign, so they don't get rejected. And that's one of the major issues if you used stem cells that came from someone else and put them into your or my body. The significance of this paper is that while this technique has worked in animals so far, it has never been made to work in human beings. So the principle is that you take an egg, the principle of nuclear transfer is that you take an egg, you remove all the DNA from the egg, so the maternal genetic material, and you add a cell that comes from the patient, for example. And then when that embryo starts multiplying, the cells that come from there can go back into the patient that gave the original nucleus or the cell without being rejected. So to get this technique to work in humans has been difficult. People have managed to get these nuclear transfer embryos to develop for a short period of time, but they've never been able to derive embryonic stem cells from them. In the current paper, what they found was that if you take out the DNA that exists in the egg before you put the cells from the patient into the egg, these embryos don't develop very far. But if you leave the DNA in the egg and you add the DNA from the patient, then these embryos will develop and you can derive stem cell lines from them.